50 years, most scientists agreed on one story, that the moon was born from a violent collision between early Earth and a Mars-sized planet called Theia. A cosmic impact so huge it blasted molten rock into orbit, rock that eventually cooled, clumped together, and became our moon. But now, a new study is challenging that entire narrative. Researchers from the Max Planck Institute for Solar System Research suggest something radically different. Earth and Theia may not have been strangers at all. Instead of a random, catastrophic smash, the study proposes that Earth and Theia actually formed in the same neighborhood of the inner solar system. They grew side by side, made from nearly identical materials, orbiting the young sun like siblings. This could explain a long-standing mystery: why the moon's chemical composition is almost a perfect match to Earth's. The classic giant impact theory struggles to account for that. This new model, it fits much more naturally. If this theory holds up, it means the moon wasn't just a byproduct of chaos. It may have been shaped by a much calmer, more predictable kind of planetary evolution. And that changes what we understand about Earth's history, from its early geology to how stable environments, like the ones that eventually supported life, could have formed. Of course, this isn't the final word. Modeling events from 4.5 billion years ago is incredibly difficult, and many scientists are cautious. But this new idea opens the door to a fresh wave of research and reminds us that even the objects we know best, like our own moon, still hold secrets waiting to be uncovered. A quieter beginning, a different origin story, and maybe a new chapter in how we understand our place in the solar system. In the vast quiet of space, something unusual is approaching our solar system, an object that doesn't belong here, and today NASA has called an urgent briefing to talk about it. This visitor has a name: 3I, Atlas. Only the third interstellar object ever detected passing through our cosmic neighborhood. Unlike comets and asteroids that orbit our sun, 3I Atlas comes from somewhere else entirely, a distant star system shaped by conditions we've never seen up close. First spotted by the Atlas Survey telescope, the object is moving with a speed and trajectory that confirm it isn't gravitationally bound to our sun. It's just passing through, on a one-way journey across the galaxy. NASA's urgency comes from what this means scientifically. Interstellar objects carry chemical fingerprints from their home systems, clues about how other planets and stars form. By observing 3I Atlas now, before it zips past the sun and disappears forever, scientists hope to capture data that could reshape our understanding of planetary chemistry. Spacecraft like NASA's Lucy mission have already captured early images, though from a huge distance. As it approaches, telescopes around the world are preparing to analyze its brightness, its tail, its composition, anything they can gather. And just to be clear, there is no indication that 3I Atlas poses any threat to Earth. Its path takes it through the inner solar system, but at a safe distance. So why does this matter? Because objects like this are messages from other stars, frozen time capsules drifting through space, carrying the story of places we may never reach. 3I Atlas is one of the rarest visitors we'll ever meet, and for the next few months, it's giving us a brief, extraordinary window into the wider galaxy before heading back out into the dark. A cosmic traveler, a scientific opportunity, and a reminder that our solar system is just one chapter in a much larger story. Far at the bottom of the world, hidden beneath endless cold and wind, Antarctica has always felt distant, almost untouchable. But today, scientists announced something that brings that distant world closer than ever. This year, Antarctica reached the third lowest maximum sea ice extent ever recorded. Every year, Antarctic sea ice grows in the winter and melts somewhat in the summer. But satellites now show that even the winter maximum, the moment when the ice should be at its largest, is shrinking. This decline is more than a number on a chart. It's a signal that the Southern Ocean is warming and that Antarctica's delicate balance is shifting. Why does this matter? Because sea ice plays a huge role in Earth's climate system. It reflects sunlight, keeps ocean temperatures stable, and influences global weather patterns. When there's less of it, more heat is absorbed by the ocean, accelerating warming and weakening the entire polar environment. And though the melting of sea ice doesn't raise sea levels, its loss can destabilize the glaciers behind it. Massive ice sheets that can add to rising seas. Think of sea ice as a protective shield. When it weakens, the giant ice shelves it normally supports become more vulnerable. Scientists caution that 1 year of data doesn't define a trend. But the troubling part is this. This low maximum fits into a pattern of widespread Antarctic ice decline over the last decade, and each new low point makes the next one more likely. Antarctica may seem worlds away, but what happens there affects storms, sea levels, coastal cities, and ecosystems across the planet. This year's record low ice isn't just a statistic. It's a message, a reminder that Earth's climate system is changing faster than many expected, and that the coldest place on Earth is sending us a warning. A shrinking shield, a shifting climate, and a moment for the world to pay attention.